Martin, thank you very much for joining us here on AU Manufacturing Conversations.
Oh, thank you, Brent. Thanks for inviting me on the podcast.
A pleasure. I'd like to know, as I do with all the guests, how you got here and what you make.
I am the General Manager of QuantX Labs. It's a little bit about the company. It's a 100% Australian-owned and controlled deep technology company. We're focused on delivering innovative situational awareness technologies to secure and enhance our defence customers' operations. We do that by developing a capability in Adelaide in our manufacturing facility for the development of precision positioning, navigation and timing products, and also quantum technology sensors.
Tell us a little about your origin story.
Yeah.
You're a uni spin-out.
That's right.
I like talking to those.
Yeah, so I've been with the company QuantX, formerly known as Cryoclock, right from the beginning. We established ourselves around 6 years ago, and as you say, it was a spin-out from the University of Adelaide. At that time, we were developing a very applied sensor technology that had very specific applications to high-performance defence radars, particularly the over-the-horizon JORN radar. And our defence customers at the time indicated that they were very keen to develop this for commercial use on the radar. And so there was a natural progression for the formation of a company because the University of Adelaide wasn't able to deliver that capability to defence.
And as you were saying earlier, you're a physicist by training.
Yeah.
Were you a physicist on that work?
That's right. For the last decades before, my role has been physics, either in a scientific capacity at a university or as an engineer at BAE Systems. But at that time, I was one of the physicists leading the team developing that technology.
The company came out of IPAS.
That's right.
And not the first company to have done so. Tell me why that place seems to do so well with spin-outs.
I think it's actually leadership from the top. So you need a very strategic purpose to do applied research and link yourselves with as many external industry partners as possible. And not just to say that, but to do it over and over and over again. And so in the executive team at IPAS, they have this banner which shows all of the industries that they've ever worked for over the last 10 years. And there must be over 100, 150 companies. And not all of those turn out into realising new spin-outs, but it shows what it's like to work or deliver to an industry partner, and then is inspiring people at the university to go their own way and realise the incredible power of ideas that are sitting inside universities all around the world in Australia.
Sure.
It's actually a passion of mine particularly, which motivates me throughout my whole career. I think I've come to realise it later in life, that there is so much untapped potential in universities, and it is so hard to extract it to something that is not only useful, but somebody wants to pay for more so than it takes to make it to a viable business.
Right.
The universities are incredible hubs, but they're also usually very insular, inward-looking. They're their own customer, generally. IPAS and a number of other institutes around Australia, they're different. They go against the grain, which is challenging inside a university system to be supported by the university at large, but if you can create that mindset in each person and that freedom to take a risk, then you can start the journey of creating a startup company. But that's only the beginning. The actual creating of a sustainable business, especially in the defence sector, that is a challenging
whole other thing.
Yeah.
Right, and so back to QuantX. What on earth is an optical atomic clock?
Okay, so atomic clocks have been around for a number of decades now. So they are clocks that are based on small atomic cells, so cells filled with atoms, a gas, basically. And there's already clocks, the clocks that are in satellites that provide the GPS signal that we have our iPhones timed on and we use Uber to navigate around in. They're all based on atomic clocks. And they have incredible stability of time, so that if I said that let's reconvene at 10 a.m. next year on Tuesday, 10th of January, you and I would reconvene exactly at that time, within a second, because there's the stability there. Existing atomic clocks are driven by microwaves, and that's what gives them their current incredible performance. We're going the next step, the next generation. So instead of using microwaves to excite these atoms and causing them to effectively tick at billion times a second, we're driving these atoms or exciting these atoms with lasers, with light. Okay, so it's a different technique altogether, and that means that this clock can tick 1,000 times more per second, more times per second. So if you had to imagine a ruler with little lines on it,
the resolution
and the resolution is just so much better. Yeah. So that's where the giant breakthrough is that we can create higher precision systems, but also make them much smaller. So instead of them being in massive, big containers, we can actually have them portable. So you can have a portable GPS system.
So that sounds like something that's quite hard to do and totally beyond my understanding. However, I don't know what you can do with it and how you can solve a commercial problem or a defence problem or any other problem.
The interesting thing about quantum technologies and these systems is that people often think that it is way beyond their understanding of what they are and what they can do, but actually they can be made from off-the-shelf parts right now. You can buy lasers that you've seen in many different applications, and you can have these little atomic cells that are in lots of other products as well, and by combining them in a unique way, you can create a quantum device right now. So this isn't the future. This is products that are being created right now. The application for them is really going to the heart of the GPS network, which has been in existence for 3 decades and has driven $1 trillion of business around the world every year. Okay. But it is incredibly vulnerable. We've become so reliant on the GPS system for finance, timing of market trading, for airport control of aircraft, for energy distribution, for radars, for navigation, for autonomous vehicles. There's just endless, and it's getting worse and worse. If that GPS signal was to fail,
It'd be chaos.
Was to be jammed or spoofed, it would be chaos. So what we're doing with these very compact optical clocks is creating alternate timing and positioning services. So it's a backup. So you either use it for defence. They're particularly concerned because they know that in a battlefield, the GPS will be jammed. Not like here in normal society, and it's less likely that GPS will be disrupted by any way. It's possible, but because we've become so reliant on it, and because defence are exceedingly reliant on it, they need backup technologies. So that's what we provide, is providing really compact, effectively like a compact GPS system on the ground. We also even are planning on launching our clocks into space, so we can provide very timely backups if the GPS network drops out.
One particular application I'd like to know more about is JORN. How is this applicable to the over-the-horizon radar?
Okay, so 3 years ago we started working with BAE Systems. Our work with BAE was culmination of 7 years of working with defence, particularly on this one Sapphire clock technology. And this particular product, our flagship product, produces the purest frequency signal on the planet, commercially available or available naturally. That produces a very pure frequency. You can imagine it's like a bell or a guitar string that you pluck or hit and it rings, but imagine something that's ringing for so long that it creates a tone that is so pure. Okay, and so this is a key innovative solution that can enhance the performance of an over-the-horizon radar. And so the way it enhances the performance is that for JORN, which is looking over the horizon, 3,000 kilometres and more, the information about the target is encoded in the return signal. So you can imagine that the return signal has information about a target, but also information about clutter, all the background noise. And the ability to discriminate the target from the clutter is enhanced by using a more pure frequency source. And so our frequency source is something like 10,000 times more pure than the existing technologies that they're using. This is where the advantage for the radar and the surveillance of the northern approaches of Australia comes from.
Is it still at the applied R&D phase, or is it being used?
No, this technology is actually decades in the making. It was actually invented by our founder in his PhD 25 years ago, and in the last 3 years we've just finished the acceptance testing of the final design, and we're about to go into production for the first tranche of products. We'll deliver 4 prototypes, first of type, that will go onto site and be tested on a live operation on the site. And then they'll form, if we pass that final acceptance, that will then form the basis of the next delivery of up to 10 more of these systems that will then go across all of Australia's radars as part of the JORN infrastructure.
And what sort of timeline would that be?
Yeah, so we're planning in our workload to be manufacturing these 10 to 15 sets of devices over the next 4 to 5 years.
Right.
Then after that, there's going to be a sustainment contract where we actually provide the deeper level maintenance of those products for 25 years.
Sure. I imagine that's something, because not everyone could fix such a weird little clock.
That's right. So we are working with BAE Systems to make sure that the design and the maintenance of that could be done by BAE Systems as a risk mitigation in the unlikely event that we don't exist anymore, being a small company. But the intention is, so we place the design and the procedures all in an accessible repository, so that it's accessible by the Prime as well.
Well, lastly, I'd like to know your opinion on the question, why is it important that Australia have a strong manufacturing ecosystem?
It's a no-brainer at the moment that the supply chain issues that is affected by small companies like this, but by every other company in Australia, is partly hinging on the fact that we're so reliant on other countries for supplying parts that we can integrate. And it's not just the direct company that we might be buying a part from, say the US, it's that supplier then needs other parts from other countries. And so it's a tangled web, and the more that we can bring construction of those subsystems locally, the more we can make a resilient system for developing these products into the future. So that's actually one of the aspects that we're working on right now, is refining our supply chain of where we're sourcing our parts. We have in one system something like 600 or 700 parts, buying from tens of suppliers. That supply chain efficiency hasn't been looked at yet by our company, but we're currently looking at that now to bring the manufacturing of electronics, of modules, of chassis closer to Adelaide, in fact, preferably.
Okay, Martin, well, that's everything I wanted to ask you, so thank you very much for joining us here on AU Manufacturing Conversations.
No worries, Brent. Glad to be here.